Hello students, I am Professor Sudhir Kumar Tewatia. I am BTech from IIT Delhi and MTech from IIT Roorkee and PhD from IISc Bangalore and DTU. So today we are starting a new series that we see some numericals. They are being repeated in one way or other every 1 year or every second year or every third year in IITG mains or in IITG advanced or in board exams. So today we will be covering this motion in a straight line in vertical direction. So we will see the various possibilities that can be seen, and if one student covers this basic derivations, then any twist in that numerical he can handle very easily. So we'll be deriving the general equations, and students will be with me in the derivation right since beginning. So I'm starting that number Pakke. As in our previous two videos, myself and Kanishk attempted one numerical from IIT G mains. So that numerical is simple, but for in advanced and in IIT G mains or in NEET exam, it can be twisted or tilted in various ways. So we will analyze all the possibilities starting from the very easy and the basic derivation in the beginning. I think they are very simple and you know all that. But in such numericals, the questions are given, they may collide or they may simply cross without collision. If they collide, then you should know two more equations. Collision. In collision, only these two formulae you should remember. Next requirement for understanding this type of question is sign convention. Sign convention is, because motion is only in one direction, that is vertical direction, so we take upward direction positive, downward direction negative. Tell me that what is the acceleration? That is acceleration due to gravity, and that always acts downwards. That means we always take in such problems G as negative, usually equal to 10 meter per second square for the ease of calculations instead of taking 9.81. So now let us start the basic derivation of this question. So this is the height. We started with h. This is u1. This is u2. With u1 speed it is thrown upward. With u2 it is thrown upward. So at what time, at what distance, and with what velocities they will cross. T, suppose they meet here. This we denote S1. This U1 travels S1. This U2 travels S2 in time T. Time is T. So very simple equation that comes to our mind, first of all, that S1 is equal to S2 plus H. This S1 is equal to H plus S2, or we can write it H equal to S1 minus S2 is equal to T is common, U1 minus U2 into T. So that gives us T is equal to H divided by U1 minus U2. So that is the first thing we calculate. This is when. This is answer. After time T, they meet. So time is H1. What is U1 minus U2? Relative velocity. So we have found the time that they will meet after time T in the flight. H1 is equal to U1T minus half GT square. So this distance we find, S2 also we find, same equation. So here they meet, we can calculate S1, we can calculate S2, any one of them. So V1 will be U1 minus GT. V2 will be U2 minus GT. So these three questions we have answered.